Hello, my name is Hoa Lam at DE Technologies. This presentation will provide a brief introduction to our innovative technology for manufacturing of rotorcraft components using advanced 3D braiding. DE Technologies is a small privately held company founded in 1993. We are located in King of Prussia, about 15 miles of West Philadelphia. Our primary focus is in the advanced warhead design and warhead prototype fabrication. We are also specialized in net shape fiber preforms and composite design and fabrications. Our composite team is highly experienced in braided reinforcement with complex geometry, typically the 3D braided composite. One of our past SBIR program involved in this technology was the SBIR sponsor Phase 1 and 2 program running between 2012 and 2015. In this program, we had successfully demonstrated the feasibility of fabricating a ceramic matrix composite fastener for jet engine. And from there, we continue our work into the 3D braided program, such as the current STTR Phase 2 program, which also involves 3D braided composite for rotorcraft components. And our facility is equipped with custom-built computer control, two-dimensional braiding machines, and 3D braiding process for near net shape and preform and composite applications. Also includes its 30,000 square feet state-of-the-art high-precision CNC facility for manufacturing of precision metal products. We have extensive experience working with the Department of Defense and prime contractors. Some of the organizations that we have worked with are the U.S. Navy, the U.S. Army, DARPA, Raytheon, and Northrop Grumman, just to name a few. In response to the U.S. Marine Corps' needs for damage-tolerant rotorcraft components without stiffness and cost penalty for the X-1 light attack helicopter, and also a high-performance structural composite for other air platforms, our approach is to apply the 3D braiding concept that was used in the development of the ceramic matrix composite fastener by scaling up the equipment and process to suit larger components for rotorcraft. The requirement for the Phase 2 program is to demonstrate the feasibility to net shape or near net shape fabrication of rotorcraft components with damage tolerant and high stiffness. In this case, the tail rotor flex beam was selected as a demonstration article, and the ability to automate and scale up the process for manufacturing is also exercised. So why is 3D braided composite flex beam is better than the baseline laminated composite flex beam? It is because 3D braided fiber architecture has through the thickness fiber reinforcement, therefore has greater structure integrity, typically damage tolerant and stiffness. This technology is highly suitable for application in the DoD and prime contractor, where low cost, high performance composite are needed. With the 3D braiding, the fiber preform is braided in near net shape and consolidated into composite using resin transfer molding process. The only machining involved is cutting the center hole and trim into length, whereas in the baseline laminated flex beam, the component is made from unidirectional fiber. Laminated composite are known to delamination due to lack of reinforcement in the thickness direction. Furthermore, the manufacturing process of laminated composites is rather costly. The process involves stacking layers of unidirectional pre-pack. Depending on the thickness and complexity of the component, the number of layers can vary from several hundreds to a couple thousands. Generally, a rectangular composite block is made, then machined into the desired shape. It is a time-consuming process and create a lot of waste. Now, with the 3D braiding process here, that the benefits is multi-directional fiber reinforcement and the lesser degree of machining involved, and the result is a better composite at lower cost. And during service, the flex beam is subjected to a complex stress state, which include axial, torsion, and bending. Now, with our 4-step plus 3D braiding concepts, these properties can be achieved by varying the fiber ratio between the axial and through the thickness, and also the fiber orientation to achieve any specific performance requirement. The ability to incorporate multi-direction fiber, use of dry fiber, and minimal machining lead to a low-cost composite flex beam with high strength and stiffness, and also good damage tolerance and enhanced fatigue life as compared to existing flex beam design. Now, the 3D fiber architecture is illustrated in the sketch to the right of the slide. Shown in this example is a 3D braided component where the yellow lines represent through the thickness fiber. The white areas represent the axial or unidirectional fiber, and the gray areas are the matrix. Now, the yellow line or the through the thickness fibers intertwine with each other and around the axial fibers, thus providing high structure integrity in the 3D fiber architecture. Now, also the component can be designed and fabricated so that it can be adapted to existing rotor system without modification. At this point, we are near the completion of the STTR Phase 2 base program. In the earlier program, Phase 1, we successfully demonstrate the concept via the fabrication of a subscale prototype 3D braided composite flex beam, and that work has been carried into the Phase 2 program, where material design development and evaluation were performed. The developed 3D braided composite has an axial property comparable to the baseline material. The flex beam design and structural analysis is complete at this point. A computational model for a full-scale flex beam prototype tail rotor is also generated. Currently, a 3D braided preform for the flex beam is being fabricated. A Phase 2 option program is expected to be awarded in the spring of this year. The option program task includes flex beam performance optimization and fabrication of a full-scale prototype 3D braided composite flex beam. In summary, 3D braided composite flex beam has many advantages over current laminated flex beam design and manufacturing. With 3D braided fiber architecture, there are many variables that can be varied to achieve any specific requirement at lower cost than existing technology in terms of design flexibility, near-net shape manufacturing, multi-directional fiber reinforcement that lead to good damage tolerance and extend fatigue life. The ability to include through the thickness fiber is shown on the right, which is indicated by the red lines, enable a composite of desired thickness to be produced in a single layer as opposed to multi-layer of fiber. as shown in the left. For the laminated composite, this eliminated interlaminar strain issue associated with delamination, which is the main cause in failure of laminated composite. And this 3D braided overcome delamination and enhance the performance of the component in many ways. We have demonstrated our technology in the phase 1 and phase 2 through the designing and fabrication of a 3D braided composite flex beam. So what's the next step? The next step is to seek opportunities in funding to design, manufacture, and test full-scale 3D braided composite component in actual systems. Also, customize prototype flex beam for the U.S. Marine Corps X-1 helicopter and other military or commercial helicopters or air platforms. Fully automated braiding equipment and process for manufacturing as well as scale up for production. We are also looking to partner with the Department of Navy and other agencies in the Department of Defense and prime contractors who are interested in low-cost, high-performance composites requiring damage tolerance and stiffness, high-temperature resistant application, and ballistic protection. The anticipated role of DE Technologies is the supply of 2D and 3D braided preforms and composites, strategic partnerships, technology support. For over 20 years, DE Technology has supplied the U.S. Navy, the Department of Defense with braided preforms and composites, precision metal products, and ballistic engineering support. I hope this presentation provides a better understanding of our 3D braiding technology. Please feel free to contact myself or Mr. Bob Ciccarelli if you have any question or would like to discuss how our technology fits your application. And looking forward to seeing you at the U.S. Navy SysCom showcase in Washington, D.C. on March 15. Thank you for your time and have a good day.